Hello dear students, welcome back. This is Dr.Jyoti Shegokar, and without wasting a time, directly we will start a topic today. As this channel comes under the chemistry in engineering, that particular heading, we have to study the different points comes under the different topics which comes under the engineering chemistry. So one of the important topic is fuel, and under the fuel there is one of the again important topic, that is analysis of coal. As we know that coal is a solid type of fuel and we have to determine what are the different compositions of the coal. So there are two different methods to determine the composition of coal. That is what is present actually in what percentages in that coal sample. So with this guys, today we will start. This is Dr. Jyoti Shegokar and you are welcome in my channel Chemistry in Engineering once again. Before that, if you are not watch this video completely, so watch it, like it, share it to your friends, and also subscribe the channel if not already, and also hit the bell button so that you can get such type of videos as soon as they are uploaded. Okay, so ultimate analysis is analysis of coal, analysis of solid type of fuel. Guys, we know that analysis is required for the getting particular assets of the coal, that is what is actually the percentage of different type of ingredients present in the coal sample. So according to the need of coal, wherever on the industrial purposes, on the domestic purposes, in the different type of commercial level, so the coal is required. So according to its need, what type of coal is required where. So there are three main points, that is price fixation, then industrial utilization, and its commercial classification. There is a need of analysis of coal. So there are two types of analysis or two ways of analysis of coal, where the analysis can be done in a groups or separately it can be carried out. So here when we carry out in a groups, it is called as a proximate analysis, which is a very recent video uploaded on this channel. So you can watch that also, so that you can get idea about proximate analysis and then ultimate analysis. So guys, today's topic is ultimate analysis, in which first we have to calculate or determine or to know, to estimate the amount of carbon. So carbon is the first point. I have written all the points here. So carbon is the first, hydrogen, nitrogen, sulfur, ash and oxygen. These are the ingredients of coal which we have to determine separately according to their percentages also. So here firstly carbon. So not individual, but carbon and hydrogen can be determined simultaneously. It is because when carbon reacts, it will form carbon dioxide, and hydrogen when reacts, it will form water vapor. So there is no any mixing or any reaction of these both products with each other. So that's why they can be calculated separately, but differently they can be the process can be carried out simultaneously, but they can be calculated separately. So here with this we will start. Carbon and hydrogen. At first a sample of fuel is considered, that is a sample of coal. So just take a particular amount of sample of coal, just consider as 1 gram or 2 gram, any amount which will be fixed for the calculations. So just take firstly the carbon and determination of carbon and hydrogen. Just consider that there is a sample of coal has been taken. So take a sample of coal and carry out the process of burning. So as soon as the process of burning start, it will be with the oxygen. We know this thing. When this carbon is treated with oxygen, there is a formation of carbon dioxide as a main product. We cannot say main product, but energy is also main thing for us. So with this carbon dioxide, there is a formation of energy also, which can be utilized for the lot of purposes. So carbon dioxide which is formed there is, we have to analyze to know the percentage of carbon. Okay, so here what we did, we have here you can see this small diagram of the two different tubes attached with each other. So this hydrocarbon means carbon and hydrogen which is present in the fuel. As we know that in the fuel with the carbon and hydrogen, lot of another things like this are present, but they are not considered. It is because we have to calculate here only carbon and hydrogen, so we will consider them only. So this, when carbon and hydrogen will treated with oxygen, there is a formation of, means just a process of burning, there is a formation of this carbon when treated with oxygen, it will give carbon dioxide as a product. Means our carbon will be locked up into the carbon dioxide as a carbon dioxide, and then it is fed with this particular tube in which KOH is present and CaCl2 is present. Separately, they are accordingly in the sequence they are present. So at first it is considered that when the vapors are produced by this burning process are fed with this tube, KOH which is present there, KOH, it is a powdered form of the powdered form which is very much we can say that it is reactive with the water, so it should be just away from the atmosphere. So it is present in this tube. So as soon as the products of this combustion, that is particularly we will consider carbon dioxide, when it is treated with KOH. So as soon as it will react with KOH, there is a formation of K2CO3 as a product. So in the form of K2CO3, that carbon has been, or carbon dioxide has been locked up into this particular type of a tube. So in this way, the carbon dioxide is locked up into KOH and it forms the K2CO3, you can see. While again the remaining product or remaining that vapors which are absorbed with this K2CO3, remaining is having the hydrogen which was already present, and when it is treated with oxygen, formation of a water vapor is there. So this water vapor is allowed to absorb into this next tube, which is a tube of CaCl2. As we know guys, CaCl2 is always responsible for absorbing water vapor wherever it is there. It is responsible for absorbing moisture, or in any form water can be absorbed in CaCl2. So when it is absorbed, there is a formation of a hydrated product, that is CaCl2.7H2O. Hydrated calcium chloride will be formed there. So here the weight of KOH tube will be taken as the K2CO3 is there and carbon is there in the form of K2CO3, and here hydrogen will be present in the form of that CaCl2 and its hydrated product, that is H2O. So in this way both the weights will be considered. So how can we calculate? Here you can see percentage of carbon. Here when once the procedure will done, we can get the weight as an observation. So weight of CaCl2 tube after passing the gas which is produced by the burning of that particular amount of the coal sample in the presence of oxygen, and in the same way for the CaCl2 tube. So in this way, here you can see guys, percentage of carbon is equal to increased weight of KOH tube. So why increased weight is written? Because there was first somewhat the weight of KOH tube itself. So after passing the gases which are produced after burning process, and it is considered that the CO2 has been absorbed in that tube, so that weight is considered, which is after the process, that is increased weight of KOH tube. So increased weight of KOH tube. So here as CO2 is absorbing KOH tube, we will consider KOH tube. So increased weight of KOH tube into 12. Now what this 12 is about? It is nothing but the molecular weight of this carbon, 12, while this molecular weight of oxygen, it is 16. For one oxygen, as there are 2 required, so it will be 32. So in this way we will get molecular weight of CO2 is 44. All we have to consider here. So here you can see that increased weight of KOH tube, which was some weight, which will be some weight into 12, which is a molecular weight of carbon into 100, as we want to determine percentage, and upon total weight of coal sample which was taken at first into 44, as it is a molecular weight of carbon dioxide. Because in the form of carbon dioxide, carbon is present, we have to also consider the molecular weight of carbon dioxide. Okay, now next is the percentage of hydrogen. Then in the same way we have got here the increased weight of CaCl2 tube also. So CaCl2 tube, it is locked up into this particular CaCl2 tube. So percentage of hydrogen is equals to increased weight of CaCl2 tube, which has been increased after passing that water vapor, into 2, which is the molecular weight of water. Hydrogen. So reaction is occurred in this way, hydrogen plus half of O2 to form H2O with energy. So that energy has been used. While this H2O, then hydrogen is having its molecular weight 2, while this half of O2 is having its molecular weight 16, and in this way we will get molecular weight of water, it is 18. So we can calculate here increased weight of CaCl2 tube into 2, that is a molecular weight of hydrogen, into 100, as because we are calculating percentage here, percentage of hydrogen, and upon total weight of coal sample into 18, which is the molecular weight of water. So in this way we can easily calculate percentage of carbon and hydrogen. I hope that guys you are getting these points. So carbon and hydrogen, as these are the very prominent ingredients of the coal, they are very important for increasing the quality of coal. So higher the amount of carbon and hydrogen, more will be the calorific value, then less ignition temperature will be required as the amount of carbon and hydrogen is high. So in this way, significance, when we want to see increasing carbon and hydrogen, there will increase in calorific value and quality of coal will be good. But in case of this hydrogen particularly, when hydrogen which is there as a H2, it will be good for the quality of coal or for the health of that coal. But as it is converted into water, that is moisture which is present inside coal, it will not be helpful for the giving energy. So sometimes the significance of hydrogen is in this way, that hydrogen, though it is when it is in the form of dried hydrogen, it will be helpful for the giving calorific value, but as this number of times when this hydrogen which is present, it is already get converted into water, and that will be the moisture which will require some another energy to get burned, and there will not remain any hydrogen. So in this way we can write the significance of hydrogen in this way, that it is not helpful for the giving more calorific value or increasing the quality of coal. Okay, with this third is a nitrogen. Now in this case of nitrogen which is present, generally it remains 0.1 to 1%, not more than that. Generally 0.3% is nitrogen is found there, but this nitrogen is totally incombustible. It is not helpful for any combustion, or it will form some oxides of nitrogen, so it is not helpful for the good quality coal. So lower the amount of nitrogen, higher will be the quality of coal. So we will require very less nitrogen into the coal sample. So here it is calculated by volume of acid. So you will think that from where this acid comes. So it is also having a particular type of procedure. In this case, unlike the proximate analysis, every time we have to consider some different type of sample of the coal. So sample of coal here, during the time of calculation of carbon and hydrogen, there was a different sample of coal, while during the calculation of nitrogen, different sample of coal will be required. So in this case of nitrogen, one of the flask which has been considered is called as a Gelda-Hulse flask. Gelda-Hulse flask, and this Gelda-Hulse flask has been considered. This flask is nothing but the round bottom long neck flask, so that the products when produced, they should not be totally get escaped directly. So for that, such type of flask is considered with this particular cork. So here in this flask, at first a sample of coal is taken. So weighed sample of coal, it may be 1 gram, maybe 2 gram. It is treated with concentrated H2SO4. Minimum amount of concentrated H2SO4 is considered with a concentrated K2SO4 or CuSO4. So from this K2SO4 or CuSO4, any one is sufficient. So just consider that a sample of coal sample, a particular amount, maybe 1 gram, then in it concentrated H2SO4 will be there. As it is highly concentrated, all the coal sample which is present is showing its total solubility into that H2SO4. So as soon as it will read with H2SO4 and K2SO4, here we will get a clear yellow colored solution of the coal sample with that sulfuric acid. So this coal sample, and now this as soon as this sulfuric acid is treated with sample of coal, we will consider only the nitrogen from the coal sample. So this nitrogen is remain dissolved in this H2SO4 and K2SO4. So in this way, that nitrogen which is present is now in the dissolved condition. Now what will happen after this? We have to proceed with this Gelda's flask and this mix this all the solution into a particular amount of NaOH, that is sodium hydroxide, as a solvent. So it is to be totally get poured into NaOH. So when it is poured into NaOH, from the NaOH it is vaporized or distilled in again some of the H2SO4 solution which is having a particular normality. So particular normal, we can say 0.1 normal or 1 normal H2SO4, it's considered in which it is collected. So when this Geldar's flask, it is having the solution, it is firstly dissolved into NaOH, a known amount of NaOH. Then now this in NaOH or nitrogen, it is present. So but that nitrogen, as it is treated with H2SO4, nitrogen now is in the form of ammonia, that is NH3, and that NH3 is present in this, as a nitrogen is present in NH3 in the form of ammonia, and then it is dissolved in NaOH. NaOH is there only one of the medium. So in this it is totally get poured. Now the solution of NaOH is now distilled, means the heating is given, and in the another container the ammonia vapors are collected. So that container which is having the H2SO4, that is sulfuric acid. So in this sulfuric acid all the ammonia gas is collected, and now that ammonia is maybe in the form of some NH4 OH by 2. In that form, that ammonia will be there, means nitrogen is there in that form. And now when this 0.1 normal H2SO4, in this that ammonia has been collected totally, now our nitrogen is in the H2SO4. Now this H2SO4 is afterwards again we can say that it is re-titrated, right? Titrated back with NaOH solution. This when once we will get the solution of H2SO4, in that H2SO4 total ammonia is present, that is nitrogen is present. Now it is titrated with NaOH solution. Titration, you know guys, one burette, pipette, conical flask, all these things. So a particular solution of H2SO4 is taken in which the ammonia is present, and that solution is titrated with NaOH from the burette. So NaOH, the amount of NaOH which is required, or the amount of H2SO4 which is there, that H2SO4 which is required, with that the normality of H2SO4 will be considered. By the proper calculation, the last percentage of nitrogen can be calculated in this way, that volume of acid, that how much volume of acid has been considered, means in that volume of acid how much nitrogen is to be is present there, is to be calculated. So volume of acid is considered from this back titration. H2SO4 is taken into the burette, and NaOH will be there in that particular conical flask, and in this way the titration has been done. So how much water, how much that H2SO4 will be required, that is calculated. So from that the volume of H2SO4 will be calculated, which is considered into this particular equation. So volume of acid, that is volume of H2SO4, it is because ammonia was collected in H2SO4 into normality of that H2SO4, that is normality, that is concentration which is to be considered, into 1.4. It is from again that particular equation 1.4, as we will consider the nitrogen. So nitrogen, it is there as a N2. So nitrogen is considered as a nitrogen is having its molecular weight 14. So 14 is there for 1.4. So we will, if we want more elaborated video, if you want, you can write in comments. So we will prepare another video for getting it totally elaborated. So here the total procedure has been occurred, and after procedure we will get volume of acid, normality of acid into 1.4, and weight of coal sample taken will be divided. So in this way the percentage of nitrogen can be calculated, which is not useful for the good quality coal. Lower the amount of nitrogen, higher will be the quality. Okay, now moving for the percentage of sulfur. As it is, I already said that here every time will require a different type of sample. Then again during the sulfur, there is taken another sample of the carbon, properly weighed sample of the coal sample. So take the coal sample and it is just burned. So whenever the sulfur is burned, it will form its oxides. This is the known thing. So when sulfur is treated with oxygen, it will form oxides of sulfur, SOX. Now when these oxides of sulfur are formed, it is washed with a this is added with a particular acid which is called as a HNO3, that is nitric acid is treated. So as soon as when this nitric acid is treated with SOX, that is different type of oxides of sulfur, there is a formation of H2SO4, which is a particular acid. Now in this acid or sulfuric acid, there is lockup or sulfur which is present in the coal sample. Now this sulfur from the sulfuric acid is to be estimated. So for that, here washings of BaCl2 will be given. Barium chloride, as barium chloride is responsible for formation of PPT of sulfur, that is barium chloride to form the barium sulfate. So when this barium chloride is treated with H2SO4, there is a formation of BaSO4. Now in the BaSO4, at last the sulfur will be locked. Is it? So BaSO4. So we will just consider the weight of BaSO4. So at first the sulfur, for the calculation of sulfur, a sample of coal is taken. It is burned with oxygen. It is considered to convert it into the oxides of sulfur. In presence of oxygen, again the nitric acid will be added. So as soon as nitric acid will be added, formation of a sulfuric acid is there, and this sulfuric acid is added with BaCl2. That it is said that the washings of BaCl2 are given. So as soon as this Ba is coming in contact with H2SO4, there is a formation of BaSO4. It is a solid precipitate. So here weight of BaSO4 will be taken for the calculation. So here percentage of sulfur is calculated as weight of BaSO4. That is, at last we took here into 32. Now what this 32 is? 32 is nothing but the molecular weight of sulfur, as we want to calculate sulfur, into 100, as we are calculating percentage upon total weight of coal sample which has been taken into 233. Now this 233 is a molecular weight of BaSO4, that is barium sulfate. As its weight is considered, its molecular weight must be considered. So it is 233. In this way, we can calculate here percentage of sulfur. Now, after that, the importance of sulfur, it is not helpful for any good quality coal. Higher the amount of sulfur, lower will be the calorific value, and ultimately lower will be the quality of coal. So, lower the amount of sulfur, good will be the quality of coal. Is the significance. Now moving towards the next, that is percentage of ash. Percentage of ash is calculated in the same way as in the proximate analysis. You can watch there, or it is simply the sample of coal is taken and it is burned in presence of in the oven by without any lid, by putting it into silica crucible at about temperature 700 to 800, and for half an hour it is there in the oven. After that it is removed, it is cooled, and at last we will get somewhat weight of that silica crucible with the fuel. With that fuel which is remain, it is nothing but the residue, or it is the ash. So by ensuring that there is nothing else present other than ash, it is proceed further. So here weight of the residue which is remain into 100 upon total weight of coal sample, we can calculate ash. Ash is always useless substance. It is not useful for any increasing calorific value, and ash is generally present only in the solid type of fuels. So it creates an hindrance during burning process. Higher the amount of ash, efficiency of the burner also, of the coal also will decrease. So for good quality coal, less should be the ash content. And at last, oxygen. Oxygen is calculated by subtracting all these calculations from the 100, as it is a percentage. So simply by the calculations only, oxygen can be calculated. So higher the amount of oxygen, there will be lower the amount of calorific value, and ultimately lower the quality of coal. You might know, guys, oxygen which is present in the coal sample, it is not required for any type of the increasing quality. Higher the amount of oxygen, there will be the lower quality of coal. Just see that when 1% of oxygen is increased in the sample of coal, 1.5% of the calorific value will be decreased. So generally we think that oxygen, when it is present, it might be helpful for the quality of coal, but no, this is not the fact. That increasing the quality if we want to increase the quality of coal, there must be very less oxygen present in the sample of coal. So in this this way the significance as well as all the procedure has been considered. If you have any question about any procedure, you can ask in the comment. But I hope that you all understood these topics. There will not be the time for just you will not get any chance for the complaint. Okay, so in this way we have studied today here the ultimate analysis of coal. This is very important. According to exam point of view, it will be asked for 5 to 7 marks, while sometimes it can be asked in a bits, like calculate only carbon and hydrogen, calculate only nitrogen, calculate only sulfur, or calculate any of the two of these ingredients, and at the same time write its significance. So in this way guys, today we have studied analysis of coal. So I hope that you will understood it properly. Watch it with a very by taking with you a pen and paper and get the notes. So thank you for watching. If you like this video, like it, share it and subscribe it. Thank you for watching total video. Thank you.